Okay. In fact, we were just kind of finishing off talking about the global wind patterns. I didn't get to really like play meteorologist. Okay, I gotta have that. Okay. So we were talking about the patterns of prevailing winds, and we said that one of the big factors affecting climate is where does your wind typically come from. Okay? If you are in an area where the wind generally always comes from the same direction, then you're going to get fairly consistent weather patterns, with the exception of the odd, major pressure change or something. Okay? Around here, right, in Alberta, we have that old saying that if you don't like the weather, you wait 5 minutes. Okay? And the reason for that is we're right on the edge, or it's not really an edge, it's more of a transition area, and we're kind of in it, between winds that go from west to east and what are called the polar easterlies. Okay? So winds that originate at the North Pole, okay, and come in kind of from the northeast. Right? We're right in the transition area for that, so our weather changes easily, quickly, okay, and often. So what we often see is areas of high and low pressure can interact with each other. Okay? That can be small scale, you just get a little low pressure area comes in, you get a little shower and it's gone. Okay? Or they can be areas that are always high or low and can kind of interfere or even dominate the local weather. Okay? So right where I drew the L there, okay, this area in here is the wettest part of North America. Okay? Around here in a year, we might get 70 centimeters of precipitation over the course of an entire year. Okay? In those areas, they could get well over 3 meters of precipitation in a year. Right? And the reason for that is low pressure areas are more conducive to the formation of clouds and precipitation. High pressure areas, okay, are more conducive to clear skies. So we haven't had too many of these yet, but I'm sure we will. Okay? Those days where you look out the window and it's sunny, but the second you step out the door, the air is going to slap you in the face. Okay? Because it's going to be minus 40. But it looks like it should be nice outside. Okay? That's usually the result of a high pressure area kind of stuck in one spot. Okay? Sometimes we call it a polar vortex because it's actually polar air. It's just doing what it's supposed to do, kind of circulate from the northeast and bring down high pressure cold air. Okay? This is only really a problem if the two things try to fight with each other. Okay? And they do periodically. All right? Yesterday I was telling you, and I think this is as far as we got, that rotation around a low is clockwise, and rotation around a high is counterclockwise. Okay? The air around these just rotates, but every once in a while you get kind of a big air mass that can get thrown off, okay? And it'll kind of just follow the path that it was thrown off at. If both of these throw off an air mass at the same time, then you're going to have warm, moist air running into cold, dry air. Right? When that happens, then you're going to get the big storms, because now you've got cold air that can take all the moisture that's in the warm air and condense it, turn it into snow or rain depending on the season. Okay? And it usually runs right along the Rockies, okay? Right along Highway 2, okay? And gives us those nightmarish conditions that we sometimes get, those multi-day snow events. Right? In the summertime, that's usually the cause of a fairly major rain event. Okay? I don't know if you guys remember back in 2013 when we had the floods, okay? But that was kind of an interaction of those things. We had already a fairly cool spring, fairly wet spring, and most of the snow was still in the mountains in June, and then all of a sudden it got warmer and it rained for like a week. Okay? And so all the snow melt and all that precipitation came at the same time. Okay? And that was the result of all of this stuff interacting. The high pressure stuff interacted with the low brought the temperature up and the precipitation in, and it was just a perfect storm, literally. Okay? Everyone kind of follow me there? So if you're living here, you're going to have fairly consistent weather because you're always under what's called the Siberian high. It's going to be cold and clear. Okay? Whereas if you're over here, it's going to be cool, cloudy, and rainy. Okay, most of the time, because you just always have a low pressure. Yeah. Making some sense? Okay, so remember yesterday I told you the way I'm going to ask about components of climate and factors that affect climate is on your unit exam I will have a picture of a map of Canada. On that map I will indicate a city with an arrow. okay, and I'll say, Vancouver or St. John's or Montreal or something like that. Okay, I'll pick a city that people are fairly familiar with, and then I'll indicate it in case you're geographically challenged. Okay, sometimes we don't remember where everything is. And I'll ask you, based on the location of this city, you don't really have to have any knowledge of the city itself, just based on its location, what factors do you think would most affect its climate and how? Okay, the expectation there is that, if I picked Okotoks, spoiler alert, I'm not going to pick that, okay, that I would say, well, the main three components affecting the weather in Okotoks would be latitude. Okay, latitude is a factor because we're quite far from the equator, which means that the amount of sunlight, so now I'm bringing in the components, right? Sunlight is one of the components of climate, will change throughout the year, okay? Varying in intensity and duration. That will give distinct seasons of summer and winter, okay? And make the temperature on average cooler than a more equatorial area. Okay. Second factor that would affect Okotoks' climate would be the altitude. Okotoks is over a vertical kilometer above sea level, and as altitude increases, temperature decreases. So I've now talked about temperature twice. I've talked about sunlight, okay? So I've got two of the components of climate covered, right? Okay, then the third thing I'm going to talk about is going to be the presence of mountain barriers. Okay, for Okotoks, the presence of the Rocky Mountains is probably, okay, the next biggest thing. And that's where I'm going to talk about precipitation and wind. Okay, we're in the rain shadow of the Rocky Mountains, therefore not a lot of precipitation makes it over, making the climate drier. Okay, it can also be a kind of a breeding ground for Chinook winds, okay, which are high-speed winds that can bring warm, dry air down, giving rapid warming periods even during the winter months. Ooh. Okay, so now I have mentioned three components of climate. I've mentioned how they affect the components of climate, and I've covered it all. Okay, that's what I would be looking for. Okay, I give you a city, you got to come up with something like that. Making sense? We're going to have this activity when we come back from Christmas, where we're going to look at the climate of a bunch of different Canadian cities and kind of analyze it. So that'll give you background for that. Okay. All right. Now, climate graphs, because this is how we're going to get the data. Okay. Climate graphs or climatograms are called either one, okay, basically can tell us what the climate of a certain area is like by really only showing us two things. A climate graph only really shows temperature data and precipitation data. Okay? It tells me when it's warm, when it's cold, when it's wet, when it's dry. But from that, I can discern quite a few details about that particular place. Okay? Does it cover wind? No. Does it cover light? Actually, yes. It doesn't look like it, but it does. Okay? Really about the only thing you can't learn about a place from a climate graph would be wind. Okay? So if I'm looking at the first one there on the left, that is from Manokwari, New Guinea, which sits right on the equator. Okay, if the green line, so the line always represents temperature, the bars always represent precipitation, and it's graphed by month down here on the bottom. Okay, so does the temperature change very much? No. Okay, would that be typical of a place that sits on or near the equator?
Yes.
Yeah, because they don't have any seasons. They might have a wet and a dry. Okay, but they're not going to have summer, spring, winter, and fall because the amount of solar radiation they receive doesn't change, right? The tilt of the Earth doesn't really affect the intensity or duration of the sunlight they get, all right? So in this place, okay, the average temperature pretty much all year long is somewhere around 25, 26 degrees Celsius, okay? So a pretty warm place. Now, if you look at the precipitation bars, okay? Those bars are in centimeters. We don't use centimeters to measure our precipitation here, do we? Unless it's snow, okay? We measure our rainfall in millimeters, yeah. Okay, if we get like 15 millimeters of rain, man, that was a big storm or a wet month. Like, it's pretty dry here, okay? Here, okay, we're looking at, in 1 month, they're getting over a foot of rain, okay? 33 centimeters worth of rain. That's a lot of rain in 1 month. Now, that's their rainy season. Okay, and then they have their, in air quotes, dry season, okay, where they would only get about 11 centimeters of rain. To put that in perspective, in 2013, we got 7 centimeters of rain, okay, in that storm. All right, so their dry season, okay, is still like torrentially wet compared to what we have. All right, so it would make sense then that a tropical rainforest would probably grow here. Agreed? Mm-hmm. Okay, that's what you'll be expected to do with a climate graph. I give you a climate graph, and I'm going to expect you to be able to interpret it. Okay, look at it, tell me where on Earth it might likely be located. Okay, what the weather is likely going to be like there, and when we talk, after we talk about biomes, be able to tell me what biome it comes from. Okay, so that could be like a tropical rainforest, or a deciduous forest, or a desert, or whatever. Okay, everybody all right with that idea? All right, now, these two graphs, their temperature lines make a bell curve. Okay, what can that tell me about them without having actually looked at the names?
That they have seasons?
Right. Okay, those two locations have seasons. If they have seasons, then I know that they are not near the equator. Okay, so these would likely be more northerly. Could I tell from the curve how far north?
Yes.
Yeah. Okay. Once it's a curve, they've got seasons. They're not on the equator. And then you just look at where the curve is. Okay? Is the curve lower on this graph than that graph?
Yeah.
Then this is further north. Okay. What if I put like the climate graph for New Zealand up here? What would that curve look like?
I don't know where New Zealand is.
New Zealand is in the southern hemisphere.
It would be the opposite of Nashville.
Yeah. Okay. For New Zealand, the temperature line would do this. Because when it's the shortest day of the year, December 21st, for us, that's when the South Pole is pointed directly at the sun. That's their longest day. They always have Christmas in the summer. Okay? Just because if one end of the earth is pointed away, the other end has to point towards the sun. So our seasons are always opposite. Okay? So you can also tell what hemisphere likely this thing is in based on which way the curve goes. If it's cold in what we would consider to be summer, it isn't where we are. Okay? All right. So that's the kind of interpretation we would want to do. Now, this place here, okay, the precipitation is still pretty good, would you say? Right? And it's consistent. There's not like a really wet time and a really dry time. It's pretty even across, right? Like the wettest month is about 13, the driest month is a little over 6. Okay, so it's getting rain every month of the year. Okay, and that's why you see what we call a deciduous forest there. We don't have deciduous forest here because we have a season where it's fairly wet and a season where it's quite a bit drier. Okay, and it's also quite a bit colder. Right, so we would get prairies here as opposed to a forest.
Alberta also has the fun season of everything's on fire.
Yeah, not everything.
Well,
Most
things are on fire.
Yeah.
Well,
and it's not even usually in Alberta. Sometimes it's in BC or Montana or somewhere else. It just decides to come here. Okay, and then if we look at the one for Anchorage, Alaska, for how far away from the equator it is actually pretty mild. Right? It's actually quite close to the ocean, and that moderates its climate a bit. Okay, but you can see here that obviously in the coldest month, right, it's down to about minus 10 degrees Celsius. Like I say, that's pretty mild for Alaska. Okay, in the summer though, it also doesn't get super warm, maybe about 14 degrees, something like that. Okay, but we definitely get that temperature curve indicating we're quite far from the equator. Okay, and you can see that Anchorage is actually pretty dry. Okay, taiga, that would be like boreal forest is the other name for that. Sometimes people are more familiar with that. Okay, the boreal forest does not require a lot of water. That's why it's on fire all the time. Okay, it's actually a pretty dry biome. Okay, the pine trees don't lose water in the same way that deciduous trees do. Okay.
Don't pine trees also need to be on fire, like to release their seeds through the pine cones?
Some, not all, but yes, there are some species of pine whose cones have to be exposed to high heat for them to crack open. They're usually covered in a resin that has to be melted or burned. Yeah. Okay, so does that make sense how we would interpret those? Hello, question?
What would like Calgary or Okotoks?
So Calgary or Okotoks, I think I actually have it here.
It's gonna be interesting.
I think that's Calgary actually. Yep. I was gonna have you guess that, but there you go. Okay, so that's Calgary's climate graph. Okay, now, does it make it look like Calgary's really wet?
Yes.
Okay, what do we know about graphs that's really important?
The measurements?
Right, we got to look at the scale here. Okay, we had a tropical rainforest that didn't have bars that were this high, but the scale was considerably different as well. Okay, this is 80 millimeters. That wouldn't even register on the other one. Okay, so we're considerably drier, and as you can see, our wettest month is quite by far June. Okay, we get the most precipitation in June. That's why we're quite prone to flooding. Okay. It's also the time when all the runoff is happening. Okay, so the two things combined. You're putting a lot of water into the rivers because of all the snow melt, and it's raining a lot more than it usually does. That puts all the moisture into the environment to build the thunderstorms that we get through June, July, and August.
I'm surprised that the winter months don't have more precipitation, because it always seems like winter just dumps a foot of snow on us, like sometime during the winter.
Oh, I'm not saying we don't get a lot of snow, but remember,
Yeah.
snow is a 1-to-10 ratio with rain. These are always rainfall equivalent measurements.
Oh.
So if we get 10 centimeters of snow, that's only 1 centimeter of rain.
Oh.
Okay, so our winter months, even though and lots of people do that. Well, we get all kinds of precipitation in the winter. You're absolutely right, we do. But I mean, when it first falls and you've got a 4-foot snowbank on each side of your driveway, right? By the time it starts to get warm, it's not that all of it is running into the gutters, it's just compacting, right? As it melts, it just compacts because those air spaces go away, okay? And it doesn't amount to a whole lot of water. Yeah. Okay, so we do get precipitation, but it's not nearly as much, right? And I mean, this December has been pretty dry. We got all that snow at the end of November, right?
But normally we get like a foot of snow dropped on us somewhere in like December or January.
Yeah, you gotta remember, these are averages, right? Last year we got a big dump, this year we've had nothing. And the extended forecast is showing nothing. So we could have a December where we actually get like 2 millimeters equivalent of snow here, right? So we would get 2 centimeters of snow. Right? It's not a lot. It doesn't add up to a lot. But when we start getting those big thunderstorms, right? I mean, you get hail and the streets are full of water because the gutters can't take it away fast enough, right? That stuff represents a lot of moisture in a hurry. So yeah, the bulk of our moisture does come through May, June, July. That whole April showers bring May flowers thing is crap around here. Okay, we get snow in April.
Why does the Northeast get so much worse hail?
Honestly, I don't know. They just seem unlucky, but there's got to be some weather pattern or weird pressure phenomena that's just there. Maybe it has something to do with the thermal dynamics of the city. Maybe because the wind does typically blow here from southwest to northeast. So maybe going over the city adds energy. I don't know. But you're right. They get it more often. Okay? For whatever reason, in the northeast, you get the hail more often. I mean, but we've had them here too. Okay? It always seems to be on grad day. Okay? We always get a big thunderstorm when everybody's fancy cars are in the parking lot. And then there's what we call the used car parking or used car lot, which is the teacher parking lot, where all the crappy cars are. Okay? Yeah. So yeah, because we had one year where everybody's car got hailed up except mine. Because I'm like, I can stay around and visit with you guys, or I can go home and keep my truck. I'm kind of antisocial anyway, so I'm all right, question, Kessler.
Why is there such a big drop between September and October?
A lot of that has to do with once you reach a certain point with the intensity of sunlight, the ability to put moisture in the air greatly decreases. Right? You also get the shift in the winds. Right? We don't get you never see a Chinook arch or any Chinook kind of stuff in June, July, or August. We just don't get them then. Right? But once you shift into that other weather pattern, we tend to get them more often. Right? So any shift that leads to drier conditions usually happens late fall. Well, we say late fall. Late fall is actually December, technically. Right? We're not even in winter yet. tomorrow is the first day of winter.
Oh, really?
Yeah, this the winter solstice, right? Tomorrow is the first day of winter. We always in the calendar, in the tropical calendar, yes. Okay, for us, winter can start in September. Okay? We've had years where you get a big dump of snow in September and it stays. Okay? So, yeah. Winter in Canada is 8 months, and then there's summer, and then there's these violent transitions that are like going from sixth gear to reverse. Okay, that happen in like May and September. All right, so is that one making sense? Okay.
And then sometimes you get snowstorms in June.
Yeah, sometimes we do. Okay, close to the equator or far from the equator?
Far, very
Really far?
Yeah.
Yeah. The temperature curve is lower than Calgary's, right? It goes down to almost minus 20 in January and December. And how warm does it get?
Like 40 almost.
No.
Oh,
Temperature's over here.
15.
Yeah, we're actually
14.
like 12, yeah, 13 maybe. It's about halfway in between, right? It's not, so it's not a super warm place, okay? And we see that the precipitation is actually kind of skewed to later on in the summer. They get more of their precipitation in June or July, August, September, even October, okay? Their spring is actually pretty dry, right? So this would definitely be more northerly. And let's look at those numbers. Are those numbers very high for the precipitation?
No.
No. When we looked at the Calgary one a minute ago, the wettest month was up by 80. Here, the wettest month is 40. Okay, is this drier?
Mm-hmm.
Okay, so what kind of biome do you think would be here? Like, are you gonna have tropical rainforest here?
No.
You're gonna have a temperate rainforest here.
No.
No, there's not enough rain, right? This is also not very temperate. This is pretty Arctic-like. Okay? Would this be maybe somewhere in the Northwest Territories?
Yeah.
Yeah, okay, or even really, it could be northern Alberta, okay, if you went far enough. Okay, Whitehorse, Yukon. So quite a bit further north, okay, and those colder climates do tend to be drier. Everybody with me there? Okay, so that's what I'm gonna ask you to do. Be able to look at a climate graph, analyze it, and tell me, okay, what's going on here. All right, let's try one more here. Oh, I don't even know if I put the city name on there. Okay, that's a weird one. Okay, temperatures on the left on this one, precipitation on the right. Is this wet or dry?
Dry.
Yeah, quite dry. Okay? In fact, some of the months are like really dry. Like there might be times where in June, the 6th month there, they might not get any rain at all, right? And is it hot or cold?
Extremely hot.
Yeah, pretty hot. Like the coldest month definitely doesn't drop below freezing, okay? And the hottest month is up by 35. So closer to the equator or further than us? Yeah, I'd say quite a bit closer, but not on it. Okay, this is still mid-latitude, I would say. Okay, it's not high latitude, it's definitely mid-latitude. Right?
I want to say that's Okotoks, but that's not Okotoks because Okotoks drops down into the negatives in the winter.
Well, and we don't, like, you gotta remember, this is the average temperature. The average temperature in Okotoks is not 35 in the summer, right? The average temperature in Okotoks in the summer is more like 24, 25. Okay? I know we've had some heat, some heat domes and stuff like that, but it's certainly not skewed that far yet. Okay? Oh, did I not even put the... I don't even have the location. I think it's Mexico. I think this was Mexico City, if I recall which place I chose. Okay, would that make sense? Okay, it's pretty dry there. Okay, and pretty warm, but it's not on the equator, so they do have seasons there.
I would have assumed it was like the desert in California.
It could be Baja. I mean, that's similar to Mexico, right? Southern United States, northern Mexico. Yeah. Okay. What about this one?
Pretty close to the equator.
I would say probably pretty close to the equator. Yeah. Okay. I mean, we're looking at it being around 30. Well, this is the high. This is the low, right? So the average would be in the middle, 27, 28 degrees every day. Okay. But here, we have several months where there's very little rain, and then several months where the rain is measured in hundreds of millimeters. Okay, where do you think this could be? It's equatorial, for sure, but it's a place that has a really distinct dry season and a really distinct wet season. What do they call the wet season in Africa? It starts with M. The monsoon season. This would be a place that would have monsoons. Okay, so typically, like the like kind of the Central Africa kind of area where you see your elephants and your lions and tigers, but no bears. Okay, in that area. But yeah, you see that kind of a pattern. Okay, those areas are actually really prone to wildfires because once they get into that dry season, it doesn't rain for months. Okay, and everything gets really dry because that area is actually more of a tropical grassland than it is a forest. Tropical rainforest has to have steady rainfall in order to build up all that vegetation. It can't have a months-long period of time where it doesn't get any moisture. Okay? So the savanna is what we call it. Okay, would have a climate graph that looks more like this. Okay, you think we can handle that? Doing that kind of analysis? Okay. All right. I had a couple of videos here, guys, I wanted to show you on the climate stuff from yesterday that I forgot to show you.
What city was it?